Hey there, Year 3. Welcome to a brand new explainer. Today, I am absolutely thrilled to welcome you as the newest recruits to the Shape Detective Academy. We've got a super exciting mission ahead of us. We are going to be exploring the fascinating, sometimes sneaky world of 3D shapes. But we aren't just going to look at them. Oh no. We are going to investigate them, decode them, and uncover all their hidden secrets. So, I've got to ask you something. Are you ready to become a full-fledged shape detective? Are you ready to solve mathematical mysteries using nothing but clues, observation, and your brilliantly sharp minds? If the answer is yes, I want you to shout yes right at the screen. Come on, let me hear you. Fantastic. All right, let's get to work. Okay, let's dive into this. Look really closely at this colorful tower. To get our detective brains properly warmed up, we have our very first case. How many cubes were used to build this tower? It's kind of tricky, right? Because as a top-notch detective, you can't just count the blocks you can easily see on the outside. You have to think about the sneaky blocks hiding underneath that are actually holding the red and green cubes up. If you can figure out how to spot those hidden cubes and convince someone else of your thinking, well, you're already well on your way to earning your detective badge. Section 1, your Shape Detective Toolkit. Because hey, every good detective needs the right tools before heading out into the field, right? The absolute most powerful tool in your entire kit is understanding this one big word, properties. Now, properties are really just the special features of a shape. Think about it like this. Just like you might have brown hair or green eyes, or maybe you wear glasses, a 3D shape has features too. These features, specifically its faces, its edges, and its vertices, are our primary clues. They are exactly what helps us figure out what a shape is, even when it's trying really hard to disguise itself. Let's practice using our new vocabulary on a very famous suspect, the cube. Look right over at this orange block. The arrows are pointing directly to our clues. First up, we have the face. That's the flat, smooth surface you could rest your hand flat on. A cube actually has 6 of these flat surfaces. Next, look at the vertex. That's just a fancy mathematical word for a corner. You know, the pointy bit where everything meets up. A cube has 8 of these corners, or vertices. And finally, we have the edge. That is the straight line exactly where 2 flat faces meet. And guess what? A cube has 12 of those edges. Now, any great detective knows you have to compare your suspects. Take a look at the blue shape there. That is a cuboid. So what's the same and what's different between the orange cube and the blue cuboid? Well, if you count them up, you'll see they both have 8 vertices, and they both have 12 edges. But here is the ultimate case-cracking clue. The cube has 6 perfectly square faces. Every single side is exactly the same. The cuboid, on the other hand, kind of stretches out. It has rectangular faces. That is the key clue that sets them apart. Section 2, solving the shape clues. Now, what's really interesting about this slide is we are transitioning into a high-energy game show challenge. We're going to use real clue tables from our case files. I'll give you the properties, and you yell out the shape. All right, I am going to whisper this first official clue table so no one else hears. Look at those details. Vertices, 0. Edges, 0. I want you to think really, really hard. What 3D shape has absolutely no corners and no straight edges whatsoever? Do you know it? Shout it out. Yes, no way, you got it. It's the sphere. It is perfectly round, smooth all over, with absolutely no sharp corners and 0 straight lines. You totally nailed it. This was the perfectly round culprit we were looking for. Okay, let's check the next file. Here is mystery shape number 2. Vertices, 0 again. So there are no pointy corners. But wait a second, flat faces, 2. How on earth can a shape have no corners but somehow still have 2 flat surfaces? Close your eyes for a second and try to picture what that looks like. What shape could this possibly be? It is the cylinder. Check out that pink shape. Do you see how it works? The top is a flat circular face, and the bottom is a flat circular face. So that makes 2 flat faces. But the rest of it wraps all the way around completely smoothly, which means it has absolutely 0 sharp corners or vertices. Honestly, that is some brilliant deductive reasoning, detectives. All right, here is your final, seemingly simple clue in this round. Look at the table. Triangular faces, 4. Other faces, 0. Okay, so this shape is made entirely of 4 triangles just attached together. No squares, no rectangles, definitely no circles. Just 4 triangles. What shape is this? It is the tetrahedron. It's also known as a triangular-based pyramid. Look at the orange shape right there. It has a triangle on the bottom acting as its base, and then 3 more triangles folding up to meet at a single point at the top. 4 triangles in total. Tetrahedron is such an awesome, big mathematical word. Let's all say it out loud together on the count of 3. Ready? 1, 2, 3. Tetrahedron! Awesome job! Section 3, comparing the suspects. Let's move to and see how this builds, because now we are graduating from just identifying single shapes to actually analyzing them and sorting them into groups. Here are your official sorting rules for this next investigation. I need you to look incredibly closely at the faces of our suspects. Group 1 is only for shapes where every single face is exactly the same size and shape. Group 2, however, is for shapes that have at least one square face somewhere on them. Let's bring back an old friend for a minute, the yellow cube. Which group does it belong to? Think about it. Group 1 needs faces that are all exactly the same. Well, a cube's faces are all identical squares, so it definitely fits into Group 1. But wait, Group 2 asks for at least one square face. A cube has 6 of them. So can a shape belong in more than one group? Yes, it absolutely can. It's a double match, passing both rules perfectly. And this brilliantly illustrates something super cool. Detectives, did you know we can mix and match flat 2D shapes together to build entirely new 3D shapes? Let's read these advanced case files. Clue 2 says the shape is built from 2 triangles and 3 rectangles, 0 squares. Clue 3 says its shape is built from 4 triangles and exactly 1 square face. Let's look at the final lineup at the bottom here, shapes A, B, C, and D. Let's match them up. Clue 2 needed 2 triangles and 3 rectangles. Look closely at shape B, the yellow triangular prism. It has a triangle in each end, so that's 2, and 3 rectangular sides wrapping around the middle. Now, what about Clue 3? 4 triangles and 1 square face. Look at shape A. That's a square-based pyramid. It sits nicely on 1 square face, and 4 triangular faces rise up to the vertex right at the top. Give yourselves a huge round of applause. Seriously, that is brilliant detective work. Section 4, the final sorting challenge. So the crucial point is, I have one last brain teaser for you before you officially graduate from the academy with top honors. If you had flat 2D pieces sitting right in front of you, how many would you need to build a 3D cuboid? And what shape would those pieces have to be? I am not going to give you the answer. Your final mission as a shape detective is to go find some materials, maybe some cardboard, maybe magnetic tiles, or even some clay, and build a cuboid yourself to find out. How many pieces did it take? Once you solve that, the mystery of the cuboid is yours forever. Good luck out there, detectives, and stay curious.